Ladies and gentlemen, welcome to very first Makrotik Mom in Nepal. I'm really excited because same as Makrotik, I didn't expect such a crowd place. It's really interesting. My name is Money. I always have to say not that kind of money, this kind of money. I wish I was, but not that much. I'm Makrotik trainer since 2011. And I'm traveling all over the world, Africa, Asia, Pacific, Europe, to train engineers and to run projects, Makrotik projects. You know that it's not possible to run the ISP, but do not use Makrotik. Nowadays, this is the way. So, all over the world, they need training, they need Makrotik, they need knowledge of Makrotik. So, I'm proud to have a student, to have friend, to have colleague all over the world, more than I think 25 countries. I'm the CTO of a company called M.IT.S. M.IT.S is located in Turkey, Istanbul. Our headquarters is in Istanbul. And you know, Istanbul is the place in the middle of Asia, Europe and Africa. You easily can dispatch everywhere. I'm in this business roughly around 13, 14 years in IT business. I'm in touch with Makrotik like 7 years. And since 2011, I think more than 10 hours a day, 12 hours a day, 18 hours a day, I'm with Makrotik. So some nights, I mean 2 times a week, I have a dream of Makrotik. Oh, what's about this project? What about that project? Anyway, Makrotik is Makrotik. But now I want to talk about the wireless deployment. But my main about deployment is not something like installation or running the wireless network. For sure, even before installation, you need a good site survey. Also, you need to have a best evaluation, link budget calculation, evaluation, a lot of things. And then you can go to deploy your wireless network. But before even deploying, even before site survey, you need to know the fundamentals. So basically, I changed the presentation name to Wireless Fundamentals because I want to talk about fundamentals. We all know what is wireless. We all may have experience to run wireless multiple times. But let's start from very basic topics. What is frequency? We all run the wireless, but what is frequency? Or what is the wireless technology that we are using? What type of signal we have? The type of a signal that we are using here in this technology is electromagnetic wave. It's better to say sinusoid electromagnetic wave. We have such a wave somewhere else. Also, lots of other technologies are using the same wave, but with different frequencies. Now, what is the frequency? Actually, frequency is just one cycle. One completed cycle of this sinusoid wave. So, one cycle is just 1 hertz. So, this signal is 2 hertz signal. So easy. When the frequency goes high, as you can see, the wavelength comes down. You see? Microwave, infrared, anything, X-ray, gamma, it's all about the frequency. Once the frequency goes higher and higher, it means the wavelength goes shorter and shorter. This is very important. I mean, this relation between wavelengths and frequency is very important. This diagram shows the available frequency ranges that we can use all over the world. The red one is FCC. It's American standard. And the yellow one is for Europe. Almost the same, but in some channels there are some differences. As you can see, it normally starts from 2.4 gigahertz. But you know, for example, in mobile technology, we are using 900 megahertz. There are some wireless devices that work with 900 megahertz, as well as some LTE devices. But normally we start from 2.4. Any device that can support frequency higher than 6 gigahertz, we call it microwave device. So what is microwave? Same technology, but microwave is a signal with a frequency higher than 6 gigahertz. So you can see it goes up to, this diagram goes up to 24 gigahertz. 24 gigahertz, you know, it's very high frequency. In normal radio, standard radio, which you can hear to, it starts with 100 kilohertz, 200 kilohertz, and then we have megahertz, then gigahertz. So 24 gigahertz is very high frequency. Although we have some 60 gigahertz even, 80 gigahertz equipment, so much higher frequencies. But let's get focused on 2.4 for a second. You know, 2.4 range, the standard 2.4 range is not really big. It consists of 11 channels. Because of this reason, in the same environment, you can have only 3 non-overlap access points, exactly in the same environment. You know, wireless is really environmental. Just a meter away, your result would be something else, just a meter away. When I say in the same environment, basically it means in the same tower, if you are using in outdoor environment, or in the same room, in the same place, in the same coverage, you can have 3 non-overlap access points. One of them channel 1, the other channel 6, the other channel 11. The other thing which is very important, you need to calculate channel separation. Channel separation is very important. If you do not have channel separation, you have interference with your neighbors. So, as you can see, minimum 5 megahertz channel separation is needed. Minimum 5 megahertz. Some documents recommend like 20 megahertz channel separation, but in most of the places, because it's already saturated, you cannot find 20 megahertz slot, free slot. It's not possible normally in most of environments. So minimum 5 megahertz channel separation is needed to be in a safe side, to make sure you don't have that much interference. Even with the 5 megahertz, you may have very slight interference, but it's not that much. In 2.4, the range is limited. But in 5 gigahertz, the range is so much bigger. Before going to 5 gigahertz, let's see here, 2.4, if you're going to choose like channel 7 or channel 11, it means there would be a kind of overlapping. You have interference with your neighbor. What is noise? What is interference? We need to figure out the difference between noise and interference. Noise is actually unwanted power. It's unwanted power. It's a power. That power can come out of the competitor device, your neighbor device, or that power could be by something else. But interference means using or sharing the same channel for 2 networks. This is interference. If you do not follow the channel separation, you may have interference. Depends on environment actually. If you're working in free environment, if there's no any other competitors, so these are nothing. But for the places like Kathmandu, because the wireless technology is booming here, everybody is running wireless. Although fiber is growing, but you know, wireless is much faster. Most of the ISPs prefer to run wireless because in 10 days they can run their company and they can serve their customers. It's so easier than fiber, so cheaper than fiber. For sure, it's not stable than fiber, but you can ensure stability by yourself. In 5 gigahertz, the range is so big. The range is so big, but in 5 gigahertz, there is a small issue here. A part of a range, we call it DFS channels, dynamic frequency selection, DFS channels. This is different with another feature which we call it ATPC, automatic transmit power control. Automatic transmit power control means access point can control the power of a station. This is ATPC, Automatic Transmit Power Control. To not to not exceed the power more than allowed one. Another feature is automatic channel selection. Automatic channel selection means you are working in this channel, but if there would be another competitor, if new wireless network runs beside your network and there would be any kind of interference, automatically it can change the channel. But automatic channel selection is different also with DFS. DFS is automatic channel selection, but it only works if you're interfering with some weather devices. We call them radar devices. Radar devices, if, for example, you're around airport or some companies that they do weather forecasting, beside those places, you need to be careful about the DFS because some of those equipments are working already in DFS ranges, DFS channels. And by law, you need to change your channel because they don't. By law, we need to change our channel. And this is automatic process in MikroTik. MikroTik already has DFS by itself. So do not confuse DFS with automatic channel selection. Automatic channel selection, or ACS, only changes the channel when you're interfering with another wireless device, another wireless equipment. But DFS only changes if you have interfering with weather radar devices. And you see it has lots of channels. It's big range. Now, for example, with the spectrum analyzer, you have already analyzed the environment and you have already selected your channel. Okay, now you need to know better to use 20 megahertz channel or 40 megahertz channel. When you increase the channel width, for sure you're increasing the bandwidth because you're going to have more spectrum to use. So you can exchange more data. But by increasing the channel width, already noise effects increases and also the power and distance decreases. Because you are using the vast amount of area and you are using your energy, your power in the very fat channel, fat pipe, so the distance and power automatically comes down. I mean, it has a reverse, it's proportional relation. So if you need high bandwidth, for sure you need to use 40 megahertz. In AC standard, right now we have 80 megahertz. So it's so big, it's so wide. So when you choose 40 megahertz, the peak comes down. The peak of the power comes down, but you can have more bandwidth. Now it's all about your calculation. How much power you need to be able to support this amount of throughput by this distance. It's all about the calculation. After knowing about fundamentals, now it's time about calculation and site survey. This one shows how 20 megahertz channel and 40 megahertz channel can work beside each other without any problem. If you have 20 megahertz channel separation, no worries. There would be no interference at all, 0%. As you can see, not even 0%. There is slight interference, but it's not in the peak power. Peak power is there. So this interference, we cannot say this is interference. There is a small, maybe 1%, but it doesn't affect that much. So if you have 20 megahertz channel separation from this side, 20 megahertz channel separation from this side, then you are safe. No interference at all. But I'm telling you, the minimum is 5 megahertz. For sure, in saturated environments, you cannot find 20 megahertz free, but depends on environment. Minimum 5 megahertz needed. Now about calculation. What you need to know about calculation of the wireless link. We call it link budget calculation. To calculate the link budget, let's assume we have a point-to-point link. Although to deploy the point-to-multi-point link, you can use the same rule. You can follow the same rule. In a point-to-point link, when you want to calculate the link budget, you want to find out how much throughput you can have. You want to find out how effective your link can be. What is important actually here? The transmit power is important. The power of the transmitter device. As more power, you can travel further. So power is important. By itself, power is important. The gain of transmitter antenna is important. What is the gain? Gain is the ability of the antenna for propagation. How effective the antenna can propagate. This is the gain of the antenna. The gain of transmitter antenna is important. Now your signal is on the air. We will talk about modulation, we will talk about other things, but the data is on the way right now. Because of noise, because of rainfall, because of obstacle, because of any problems, any reason, the amount of signal, the amount of power will lose by traveling the distance. Even if there is no obstacle, there is no noise, there is a concept, we call it free space path loss, FSPL, free space path loss. It says, by traveling on the air, you're going to have attenuation soon. If I'm not using this microphone, you cannot hear me. This is attenuation. All about FSPL. So by traveling on air, even if there is no any problem in this transmission, there would be attenuation. So FSPL should be calculated. FSPL is free space path loss. Also, if you search online, there is another calculator. There are a bunch of calculators. FSPL calculator. So before this calculation, you need to use FSPL calculator to calculate the FSPL first, and then you can use the value in this calculation. Transmit power of transmitter device is important. The gain of transmitter antenna is important. FSPL is important. Now, the signal arrives to receiver side. The gain of the receiver antenna is important. How effective your antenna can listen to the signal. This is the gain, but in the receiver side. Also, there is a concept in receiver side, we call it RX sensitivity. How effective your wireless card can sense the signal. How low signal your wireless card can hear. This is RX sensitivity. When you get the wireless device, wireless card, for sure the factory mentioned this information in a data sheet. RX sensitivity, same as TX power. Same as TX power, same as antenna gain. These are information that provided by factory. Something which is not included here, but I prefer to mention, is the loss. Because between the radio and the antenna in transmitter side and the radio and antenna in receiver side, you may have a small loss, like 1-2 dB loss, sometimes 3 dB loss, depends on a cable and connectors you are using. You may have loss. If you want to have the most accurate calculation, it's better to calculate the loss also here. But for example, if you are using SXT, Makrotik SXT, there is no loss because antenna is already attached to wireless card. No cable, no connector. So if you are using integrated devices, no worries about loss. There will be no loss. But if you are using radio separated and also the separated antenna and you connect them by cable using N female or any other connectors, you may have minimum 1-2 dB loss. So it's better to calculate loss in here as well. This is the single carrier signal. Means this is only one of the spectrums that you are using to transmit. But when you are using 20 megahertz or 40 megahertz channel, it means you may have bunch of these carriers. We call them carrier. Basically, they are a carrier, but carrier normally is the name of the middle signal. For example, you have selected for example, 5550. Your signal is 5550. Your channel is 20 megahertz. So your channel is wide from 5540 to 5560, and 5550 is in the middle. So 5550 is the carrier signal. We call it carrier signal. But actually, each of these spectrums can carry your signal. So when you are using wide channel width, like 20 megahertz or 40 megahertz or 80 megahertz, you can have more throughput because you are using more spectrum. Now about the signal propagation. Normally, a sinusoid signal should propagate like this, continuous waveform, exactly in the same shape. Normally should be like this. But because of any reason, because of environmental issues, actually your signal is not really continuous like this. Your signal would be something like those. Because of anything, rainfall, obstacle, noise, interference, because of any problem in wireless transmission, your signal may be like that, not really continuous. Then here we need a modulation to be able to maximize a throughput. Then here is the concept of modulation. We have different types of modulation. Later on we will talk about the modulation, but to be able to have high throughput, we need a modulation. Without modulation, it's not possible. Actually, modulation is not only for wireless technology. Musicians are using modulation in physics, because this is the physics concept. Also, we are using here in modulation. This microphone also does modulation, but different types of modulation. There are two things that affect your link. One of them is RX sensitivity. I told you about RX sensitivity. It's the amount of a low signal that your wireless card can hear. Manufacturers nowadays, they try to make the lowest RX sensitivity, like minus 90. Minus 92 dB. This is very low signal, minus 90. Those who are familiar with wireless, they know that minus 90 is very low signal. Actually, the amount of noise is minus 90, minus 100. So RX sensitivity shows how low signal you can hear. The other concept is selectivity. Selectivity means the ability to listen only to desired signal. This is the way how you can avoid noise effect. Selectivity. Your router, your wireless device should be able to select desired signal. But because of noise or interference, your selectivity comes down. For example, you're overlapping with another network, so your selectivity is not only listen to your own signal, it although receives the neighbor signal as well. This is the comparison of channel width. You know, the standard channel width is 20 megahertz. This is the standard. You still can have 5 megahertz or 10 megahertz. For example, you are in installation, your channel width is 20 megahertz, but your signal is so low. Because of any reason, your signal is low, because of noise or whatever. You're bringing down the channel width. Instead of 20 megahertz, you are using 5 or 10 megahertz. So it means you can, by reducing the channel width, you can increase the power level and you can increase the distance. But the bandwidth might be lower. Maybe in that project you don't need a bandwidth, you need stability. You need to be stable more than having bandwidth. Maybe 5 meg or 10 meg is enough for you. So you can make your link stable by changing the channel width. In noisy environment, in low noise environment, selectivity is really good. Selectivity is nothing that be able to change. You cannot change this option. This is not the option to change. Selectivity is the characteristic of the device, of the wireless card. So in low noise environment, selectivity is really good. You can select only desired channels. But in high noise environment, selectivity is not that much good. So in this way, noise affects your transmission. Now about the modulation. Why we need the modulation? Because we cannot have continuous waveform. We need modulation. What is modulation? Modulation is changing or varying some properties of the signal itself to be able to have continuous waveform. You need to be able to change the properties of the signal. For example, a phase of the signal or amplitude of the signal, or frequency of the signal. Sometimes you need higher frequency, sometimes you need lower frequency. Sometimes with low amplitude, your wireless link works fine, but sometimes you need to have higher amplitude. So, modulation is changing the properties of the signal, no matter amplitude, phase, or frequency. So basically, in wireless technology, we have 3 types of modulation: FSK, ASK, PSK. We call them basic modulation. These are basic modulation, but for wireless technology. Can you remember AM, FM? Those are radio modulation. These are wireless modulation. Those are analog modulation, AM, FM or something. Modulation is a huge topic. If you Google it or if you check it out on Wikipedia, there is a document like 200 pages. Modulation is very massive topic. And understanding modulation leads you to have very stable wireless link because it's all about modulation. Without modulation, normally, with the basic modulation, you cannot have a good throughput. But sometimes, because your signal is low, when you increase the modulation, your link is not stable. So everything relates to modulation. This is something we call it constellation diagram. Constellation diagram is something that helps to understand this type of transmission. For example, in BPSK, PSK, if you can remember from here, PSK is phase shifting key. So it's a type of modulation that you need to change the phase of the signal. BPSK means binary phase shifting key. Means binary, means at the same time you are transmitting 2 symbols. This is the first one, 0 the first one, 1 the other. In BPSK modulation, at the same time, you are transmitting 2 symbols. Each symbol can have 1 bit. This is BPSK. So it means at the same time, you can transmit 2 bits. Binary, 2 bits. This is BPSK, the lowest modulation rate in wireless technology. Error vector magnitude, or EVM, shows the effect of problems like noise and interference in your transmission. For example, let me show you this. Normally, when you transmit a symbol, You need to receive, when you transmit in this position, when you send in this position, the receiver side should receive in exact position here. But because of noise or interference, sometimes you receive it in different area. If you are still receiving it around this area, it means you can extract the data. It means you can have readable data. But if this symbol comes here, or wherever else, this data is not readable. Then you need to retransmit again. We call it retransmission. What is retransmission? Because of the effect of noise or whatever, noise or interference, the packet, or better to say the frame, losses on the way. This is packet loss or frame loss, because this is layer 2 technology. Better to say frame loss. When you have a frame loss, you need to retransmit again. This is retransmission. And EVM, the amount of EVM shows the amount of retransmission, or how clean you can receive your symbols. So EVM shows the level of quality, actually. Better to say like this. So in BPSK, you, at the same time, you are transmitting 2 symbols. In each symbol, you are transmitting 1 bit. For example, the wave, if you want to transmit 0, the waveform is like this. If you want to transmit 1, the waveform is like that. So, when you are transmitting continuous 0, there is no problem. You can continuously send out zeros. But when you want to send 1, 0 and 1, 1, there is a congestion here. So you need a modulation to change the phase and continue. This is PSK, phase shifting key. You need to change the phase of the signal, because 0 is like that, in that shape, 1 is like the other one. QPSK is quadrature PSK. It means at the same time you are transmitting 4 symbols, and in each symbol you have 2 bits. So, more bandwidth. This is QPSK. BPSK, QPSK. Also in QPSK, you have different shapes for different symbols. These are different types of shapes for transmitting QPSK. This is how it operates. Now, 16 QAM, 64 QAM, 128 QAM, these are advanced modulations. 16 QAM means 16 quadrature, but amplitude, not phase, amplitude modulation. This is another type of modulation, but 16 means at the same time you can transmit 16 symbols. In each symbol you can have 4 bits. So, more bandwidth. By increasing the modulation, if the signal strength allows you to increase the modulation, then you can have more bandwidth. You know that with the last standard, wireless standard AC, you can reach up to, over 1 gigabit per wireless link. With the last standard, 802.11 AC, you can have over 1 gigabit per second. Also, there are some other techniques like link aggregation, like macrotic bonding. You can have 3 wireless links or 4 wireless links, each 500 megabit. Then you can aggregate and have 2 gigabit wireless link. Each of them also can be the backup of the other. They all can work at the same time. You can aggregate all together. But if one of them goes down, automatically the other one is operational. So 16 QAM or 64 QAM is getting more advanced and more advanced and more advanced. In 64 QAM, At the same time, you can transmit 64 symbols. In each symbol, you can have 8 bits. So, something like double bandwidth. Not only Makrotik, but all wireless manufacturers have a feature called automatic modulation or automatic data rate or data rate adaptation with different names. This is all about the modulation. It monitors your signal strength. If the amount of signal strength allows you to use 64 QAM or 128 QAM, here we go. Otherwise, automatically brings down the modulation. So sometimes you see that you're working with very high bandwidth, but tomorrow, for example, your bandwidth is less because of environmental changes. Environmental changes affect your wireless link, then wireless device automatically brings down the modulation, so your bandwidth is half today. This is something that we call it fade margin. You need to calculate minimum 50 dB in signal. For example, if you need 65 minus 65 dBm as a signal strength, then go for 50. Calculate 15 dBm, although 15 is too much. 10 is, if you need 60 dBm, minus 60 dBm, try to align for minus 50 dBm. This is fade margin. Now, if you are working in minus 50, in case of rainfall or huge fog, it comes up, it goes down up to minus 60. Then you still have good modulation. So if by your calculation you find out that you need minus 60, try to get minus 50. And leave that 10 dB for fade margin. 256 QAM at the moment is the highest modulation rate at the moment. So with this modulation you can achieve over 1 megabit. Now at the end, because I want to show you how these informations, how fundamental is important, I just want to share with you how environment can crazily be saturated. In Lagos, in Nigeria capital called Lagos. These are some towers in Lagos. Believe me, this is nothing, but because I was so close, I just took a shot. Over 50 devices. How you can find free frequency here? Just take a look. It's crazy. Even you cannot climb. So for this type of tower, it's really interesting to show you the spectrum analyzer. We have been analyzing for a week to find a free channel. Not a free channel, least noise, least interference. As you can see, the average, this is noise. The average of noise is something like minus 60. Minus 60 is the average of signal you need. This is very high power. This is the highest noisy environment I have ever seen. As you can see, in some places it reaches even minus 25. So the goal of wireless engineer is finding the channel in this environment, in this jungle. This is the wireless jungle. This slot is free. This slot is free because in Nigeria they are not allowed to use this slot. It's licensed. Depends on the country. Regulation is different. In Pacific you may be able to use it. Not all over Africa, but only in Nigeria they are not allowed to use. Anyway, wireless technology, when most of you maybe have this experience, you wanted to convince your customer that instead of running cables, fibers or whatever, it's better to run the wireless link. I know they always try to not get convinced, but you need to convince them. Wireless is really stable. if you have a good calculation, site survey, good alignment, good installation, and also monitoring. It's not like this, when you installed, then leave it for itself. You have to monitor it every day, every week. With applications like Dude, you can get automatic notification. For example, with Dude, you can set if the bandwidth or signal strength would be lower than something, you want to get messages, you want to get email or something. So, when you want to convince your customer, tell them wireless is stable if I install it. Then they will be convinced. Any questions about the wireless? Although we're going to start Democratic trainings from tomorrow, full course, everything from the very basic up to the advanced, depends on what you need. Mr. Roshan is somewhere around, you can talk with him about Democratic official courses. You will be able to take certification at the end if you can pass the exam. Anytime you can find me by these details. I'm always available in Skype. I'm 24/7 online in Skype, but if I'll be in class or presentation or event, it may take like an hour to respond, but I'm always online. Actually, I'm gonna die if no internet. So you always can find me, but it may take a couple of hours to respond. Thank you very much. Good luck and enjoy your mom.
Thank you, Mani, for your presentation. And the next presentation will be from Andy Morrison. So if you're ready, please.